So, let's begin with today's lecture. And today's lecture is the most interesting and a common topic which we have already studied from our previous chapters of our life, right? So, today's topic is about Ohm's law and Kirchhoff's law, which is basically in the background of current, potential difference, and resistance. So, let's move on. Ohm's law. What does it basically mean? Okay, current through an ideal conductor is proportional to the applied voltage. See, basically this statement states that current is directly proportional to the voltage. If we increase the current, then the voltage will, or the potential difference will also increase. Okay, conductor is also known as resistor. We know that conductor is a system. Conductor is basically a part which states that it allows the flow of the current. So it is also known as a resistor because resistor also allows the flow of a current. An ideal conductor is a material whose resistance does not change with temperature. Always remember that whenever there will be ideal conductor, though the temperature changes, though it increases or decreases, or it remains same, there will be never be change in the resistance part. Okay. For an ohmic resistor, voltage is equal to current into resistance. That is, V is equal to I into R. And we know that V is equal to voltage, I is equal to current. Okay. And voltage, we resemble it as volts. Current's unit is ampere. R is, here is the resistance. So R we always, that is the resistance is always denoted with the unit ohms. Okay. And for being an ohmic device, it needs to follow this particular law, that is the Ohm's law. Now we will know current and voltage and how we define it. Okay. What is conventional current? The current in electrical circuits. Any current which is in electrical circuit is a current. Okay. Flow of a current from positive terminal to the negative terminal has units of ampere and is measured using ammeters. See, if there will be a circuit, we need to measure current. So for measuring current, we need any device, right? So we will use ammeter for measuring current, and we know that current unit is ampere, right? Voltages. Energy required to move a charge from one point to another has units of volts and is measured using voltmeter. Okay, see, if we require to measure a current, we also require to measure voltage. So for voltage, we use voltmeter. Okay, and we know that its a unit is volts. Okay, and this is done because any energy which needs to be moved from one point to another, we know as it as voltage. Think of a voltage as what pushes the electrons along in the circuit. Okay, think that the voltage is a type of electrons which pushes along the circuit, and current as a group of electrons that are constantly trying to reach a state of equilibrium. See, if voltage pushes the electron and current is a group of electrons, then which are constantly want to become a state of equilibrium. So basically it's an example. Okay. Now ohmic resistor. What is ohmic resistor? Metals obey Ohm's law linearly so long as their temperature is held constant. Okay. See, ohmic resistor is said to be ohmic when it will follow Ohm's law, right? And what is linearly? Linearly basically means whenever the current will increase, the voltage will also increase. But current is always inversely proportional to the resistance. That means if the current increases, the resistance will be low. Okay. Now, their resistance value do not fluctuate with temperature. But for ohmic resistance, their resistance does not fluctuate. the resistance for each resistor is a constant. For each resistor, the resistance will be constant. Most ohmic resistors will behave non-linearly outside of a given range of a temperature or pressure. See, ohmic resistor also have some advantages as well as disadvantages. If it is not between any ranges of temperature and pressure, then it will behave as non-linearly. So one of, you can say, it can be a disadvantages of ohmic resistor. We saw the video, right? So what did it say? That whenever we increase the current, the voltage will increase linearly, right? So see, here when it's at 0, that is the current is at 0, the voltage is also 0. Whenever it's 0.1, the voltage increases. When it's 0.2, the voltage again increases, and it increases in a linearly straight line. Okay, so this is a graphical representation between voltage and a current relationships for linear resistors. Okay, and voltage and current are linear when resistance is held constant. See, voltage and a current will only be linear, that it will be in straight line, not vertically, slightly tilted straight line, then only when the resistance will be held as constant, that there will be no fluctuation in the resistance. Okay. Now Ohm's law. Ohm's law, we have two parts of circuits. Okay. So let's read the statement first. The total resistance of a circuit is dependent on the number of resistors in the circuit and their configuration. See, the total resistance of a circuit. Think there are 5 resistors, R1, R2, R3, R4, R5. Okay. And the total resistance, that is the R total, will depend on all the 5 resistors. So basically, when it will be in series circuit, the R total will equal to R1 plus R2 plus R3 plus R4 plus R5. And if there will be more resistors, then it continues. But in parallel circuit, it will be inversely, that is 1 by R total equal to 1 by R1 plus 1 by R2 plus so on. These two equations stated the same. Okay. So now let's watch a video which will clear all your doubts about Ohm's law. Now we can see a bulb and a battery for the flow of the current. We will use ammeter to check the current flow, and for the potential difference, that is the voltage, we will use voltmeter and will put it in the 2 terminals of the bulb with a constant temperature. Now we will notice the units in the ammeter and the voltmeter. But now we increases the current and we can see that the voltmeter also increases. It states voltage and current is directly proportional to each other. I hope all your doubts got clear. What is Ohm's law and how it happens? So we come to the end of today's lecture. Now it's a good time. Never cheat yourself. Do your work always on time. I hope all of you understood today's lecture and thank you for watching. Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.